Hi everybody, here we are with our video lesson over R.2 Day 2. I'm going to talk a little bit about some order and some absolute value stuff, and then we're going to complete the rest of the notes page in class tomorrow. So just make sure you get this basic stuff copied down. Make sure you circle or star or highlight any questions or issues that you have with this information. And then tomorrow we're going to talk about some more absolute value stuff, okay? I'm going to jump right into this first part, which is just about ordering numbers, putting numbers in order. And one really important thing that you need to make sure you're paying close attention to is whether or not it wants it in order of least to greatest or greatest to least, because sometimes we'll switch back and forth. So make sure that you don't make a silly mistake regarding that kind of stuff. But let's talk about how to order just this very first example here. We're ordering these from least to greatest. And so what I like to do, I think best in decimals. And so what I'm going to do is kind of translate each of these into a decimal. 6 is already a decimal. 2/3 you know is 0.666 repeating, or 0.6. And -11 we've already got. Radical 9 you know is just 3. Pi, you should recognize that symbol, 3.14. Radical 12, I'm going to skip that for a second, but 10/2 you know is 5. So here's something kind of crazy, is that how do you do radical 12 without a calculator? And I know that you can type in radical 12 into a calculator, it's going to give you a decimal, but I want you to use some common sense, and I want to see if you can give me an estimate as far as what that number might be around. Because keep in mind, we don't need to know exactly what that number is as far as the decimal goes, we're just trying to put it in order. So think about this. You know what radical 9 is? It's 3. You also know what radical 16 is. What's that? 4. So can you give me a decimal estimate as far as what radical 12 is? It's going to be somewhere between 3 and 4, right? Like 3.5. Take a guess. You can figure out, you can narrow it down as far as what it's going to be in between. So I'm going to put like 3.5. I'm going to put little squiggly equals because that means it's about 3.5. I'm not exactly sure what it is, but I can use that information and common sense to put these numbers in order. So now what we're going to do is go back and we're going to put these in order from least to greatest. And least to greatest, be careful with your negative numbers. -11 is the least number that we have here. And then the next negative number is that negative radical 12. So that one goes next. Let's see, what is after that one? I have the 2/3, which is 0.6. I'm also going to kind of cross these out as I use them, just so I don't get confused. What would be next? Radical 9, right? Because that's just 3. Use that one, and then pi is right after that. That's 3.14. And then I have 10/2, which is 5. And then 6 is my greatest number. So here we are, from least to greatest. There we go. Let's go to the next one. You might not have ever seen before how to do radicals like that and put them in order, but you can see we have another one here, radical 26. Give me an estimate as far as what that one is about. Well, you know radical 25 is 5, right? So radical 26 is going to be just over 5, like maybe 5.1 or 5.2-ish, whatever that is that's closest to it. I'm also going to get decimal equivalents for these other ones. 4/3 is 1 1/3, or 1.3 repeating. 15, E we learned about in one of our first sections. That's a decimal that is 2.718, and we will use that number a lot later in this course of this year. Negative radical 4 is just -2, and 15/3 is 5. So again, we're going least to greatest. I'm going to take my smallest negative number first, which is -3. My next negative number is negative radical 4. I've done that one and I've done that one. What would be next? I've got 4/3, which is 1.3 repeating. After that one I have E, which is 2.718. And then I have 15/3, which is 5. And then I have the number that's just past 5, radical 26, and then 15 is definitely my largest number. So using some common sense in order to figure out how to put these numbers in order is all we're doing. Okay, I'm going to give you a definition for absolute value, and it's going to be a little bit of a crazy definition, but this is one of the things that we're going to talk about tomorrow. So just get this definition copied down, and then I'll explain it a little bit better in class tomorrow. So the definition for absolute value of A, I know you've probably seen those symbols before, but if you can think about, I'll give you an example first. Do you know what the absolute value of 5 is? It just means the distance 5 is away from 0. So the distance from 0 that the number 5 is 5. And so what about this one? What about if I did -3? What's the absolute value of that? Well, it's just +3, right? It's 3 spaces on the number line away from 0, and that's what absolute value is asking you to do. So basically we have two cases for absolute value. What if A is positive? And then what if A is negative? We have two different cases. So let's look at the example that I did over there on the left. If A was positive, so that was when I did 5, what was the answer? It was just 5. It was just whatever that A number was. The answer is just A. And if A is negative, so that was my -3 example, what was the answer of the absolute value of -3? It was +3. And so basically all I did is I got rid of that negative sign. And so I'm going to use the word opposite. I took the opposite of -3, which gave me +3. So opposite in math, we have a symbol for that. It's a negative sign. And so just make a little note to yourself here that the negative means opposite. It doesn't always mean negative. The answer wasn't negative, but I negated the negative sign that was already there. So a little bit confusing, but that's kind of our definition, and that's why we have two different categories. And so just keep that in mind, and I'll expand upon that in class. Let's do something a little bit easier. We'll return to the absolute value stuff tomorrow, but that's the mathematical definition. And what you'll learn, especially in this class, is that sometimes mathematical definitions are kind of weird and crazy looking. But then once we do a couple examples, you'll get the hang of it, and you'll kind of understand where the definition came from and what it means. Okay, so let's do these 3 examples, and then we'll deal with the absolute value tomorrow. So we have 3 examples left. Let's talk about some absolute value symbols and how to simplify expressions that look like this. Basically, you treat the absolute value like parentheses. You have to do parentheses, exponents, multiplication, division, addition, subtraction. So remember your PEMDAS and what that means. We are still using all of our PEMDAS rules and properties on these examples. So I'm just going to continue simplifying kind of as I go through here. 3 minus, I know 4 squared is 16. So I'm simplifying that, keeping that negative sign, and then I know the absolute value of -3 is just 3. So I can get rid of that absolute value part. Basically this negative sign is here, and the -3 in the absolute value went to there. So just kind of keep that in mind. I'm going to erase my arrows. That's what that kind of stuff came from. And then I also have the denominator here. And the denominator is just addition and subtraction. You do that left to right. 25 minus 10 is 15 plus 3 is 18. So it's just left to right. Okay, so I'm going to continue simplifying. I can do the absolute value part, the 3 minus 16, that gives me -13. And I'm getting a little bit more simple every single step that I do. And I like to show all my work so I don't do anything in my head and get really confused. There's actually a lot of steps going on here. Absolute value of -13 is +13. 13 minus 3 is 10. And always reduce the fraction if you can, always. Never leave it not reduced. Always reduce if you can. Okay, so there's my first example. Order of operations I followed the whole time. And now here we've got actually X, Y, and Z up here kind of in the directions. There's a couple homework problems that look like this too. So you'll just have to kind of replace the numbers as you go. And I like to use a lot of parentheses, especially because a lot of these numbers are negative. So I'm going to plug in my numbers first and not do any math. I'm just going to do some plugging in. So X is -1, so I'm taking -1 to the 5th. And I'm going to subtract Y squared. Y is 3. Minus my absolute value, I'm putting -1 in for X. They've got a lot of absolute value signs in the numerator and a lot of negatives, so just be careful and make sure that you're writing really clearly and not doing too much math in your head because you get really confused. And then I have -4 times -1 minus Z is -2. That's a double negative. I'll change it later to the plus positive. plus the absolute value of 3. So now I'm just going to go kind of one at a time and treating the absolute value bars like parentheses. So when I start on the left with my -1 to the 5th, -1 times -1 times -1 5 different times is still going to be -1. And then I have my minus sign in the middle, and I know that 3 squared is 9. Minus, and this minus sign is this minus sign, so be careful. And then the absolute value of -1 is just 1, so I can get rid of that absolute value. And I'm going to do the whole denominator here together. The -4 and -1 is just 4 when you multiply. The double negative changes to a plus positive, and the absolute value of 3 is just 3. So in the denominator I have 9. Now I can simplify the -1 minus 9 in the absolute value. That gives me 10. And I'm just continuing to simplify as I go. The absolute value of -10 is 10. That gives me 9 over 9, which is 1. So that entire expression simplified really easily to just 1. So that one ended up being a nice simplification. And I've got one more. I'm going to try and keep my x, my y, and my z in the window here. But I'll change colors so it doesn't get confusing. I'm going to keep my absolute value bars. I have a negative and then the absolute value of x, which is -1, plus y is 3. And that's all in absolute value bars. So I try and make my absolute value bars much longer than my ones, just because it gets confusing if it looks like you have a bunch of ones in the numerator. So just kind of be mindful of that. And then absolute value in the denominator, x squared, so -1 squared, minus z is -2. So I'm going to put that double negative there. Okay, so now I've plugged everything in. Now I can kind of simplify. In the absolute value of the numerator, I have negative, and the absolute value of 1 is just 1. So be careful, this negative sign is that negative sign. And then my absolute value of -1 turned into 1. The plus sign, and then 3 to the third is 27. Just be careful, it's not 3 times 3, it's actually 3 times 3 times 3. Be careful about that. Exponents and multiplication are very different. -1 squared is 1. Change the double negative to a positive, and I get 2. So now I can actually simplify. I have the absolute value of 26 over the absolute value of 3, which is just 26 over 3. You could change it to a decimal, or you could just leave it as that reduced fraction. You don't have to change it into a mixed number. Okay, so that's all we have for today, you guys. I know I went a little bit fast, but you can back up and re-watch any of the examples that I went through. You can pause the video if you need to pause and kind of fill in your notes packet. Make sure you circle or star, excuse me, or highlight any questions that you have that were kind of unclear. And we'll finish the absolute value stuff tomorrow, okay? Good job on your video. I'll see you later.